You're welcome to the class once again. I'm your physics instructor, and today we want to talk about something that is very important in physics, and it's a topic that a lot of students have asked me questions about this particular topic, and I'm going to share it with you today, and you will love this topic. It's a non-uniform accelerated motion. There are some, in the course of motion, there are some time in the course of motion when the velocity or speed of a motion is not constantly changing with time. When it changes, it's not constant with time, then it shows that that motion is non-uniform. So when the speed, when the distance, when the displacement, when the velocity, let's start with speed. When the distance, when the rate of change of distance of a body is not constant with time, then that speed is a non-uniform speed. When the displacement, velocity is displacement divided by time. When the displacement of a body, the rate of change of displacement of a body is not constant with time, then that body has a velocity that is non-uniform velocity, because the rate of change of displacement with time is not constant. When the rate of change of velocity of a body is not constant with time, then we say that the acceleration of that body is a non-uniform accelerated body, because the velocity is not changing with respect to time, or not constant with time. Now this is it. I'll give you an example of bodies that have that kind of behavior, which you are used to, but you may not know that that body, that particular instrument or equipment measures non-uniform motion. A great example of it is a speedometer. When you are driving a car, you observe that when you are driving, okay, probably you are driving from city A to city B. You're driving from city A, you're driving down to city B. You observe something that if, for example, city A to city B is about 400 kilometers, let's assume, you observe that you're moving from A down to B. The motion, the change in velocity is not always constant with time. How? When you are moving, maybe when you get to this place, you apply brake, you slow down. Maybe that's from here to here. Maybe you are doing maybe 6 kilometers per hour. Maybe you get to this place, you are faster down to this place. Maybe here you are doing like 7.2 kilometers per hour. You observe that at every instances of your motion, there is this kind of thing that happens, that it is not constant. You may be fast here, you'll be slow, you're fast, you are slow. Sometimes you have to apply brakes. Sometimes maybe there is traffic, and so on and so forth. So anything can happen. So that kind of motion is not, the rate of change of the velocity is not constant. The velocity change is not constant with time. So because of that, it is called a non-uniform, because it's not uniform. If it is uniform, the time you start at this A, you'll be running with the same kilometer per hour till you get to B. You won't stop. That is a uniform motion. But a speedometer of your car can never measure a uniform motion. It will always measure a non-uniform motion. Now, that non-uniform motion, there is a name we call it. It is called instantaneous motion. The reason why we call it instantaneous motion is because that the motion is being measured at every instances. So it is called instantaneous motion. So I can clean this topic off and rewrite it as instantaneous motion. It will be correct. So some of your textbooks will write it as instantaneous motion, and some will write as non-uniform accelerated motion. So it is the motion that is measured at every instances. It is never uniform. So your speedometer will measure that. So when you are inside your car and you're driving, you look at the speedometer. Know very well that the speedometer cannot measure a uniform motion. What it measures is a non-uniform motion, which is an instantaneous motion. Now, class, let's get a graph of how an instantaneous motion looks like. Now listen, I can have something like this. The motion of that body is something that it goes. You have something that looks like this. So because of that, it is not uniform. So because it's not uniform, you have to start calculating, taking slopes at every instances. At every instances. At every instances. Because it is not uniform. That is the velocity, probably displacement, with respect to time. So you observe that it's not uniform. So because it's not uniform, automatically you will be having different slope at different time. And in a displacement time graph, for a displacement time graph, what do you get in a displacement time graph? Divided by time. That will give us velocity. So in a displacement time graph, you get velocity. So at every instances that you are marking out, you are having different velocities. Different velocities. So that is why it is called an instantaneous motion or a non-uniform accelerated motion. Now, that is that, class. So from here, it is easy for us to now draw a value from here. So that is the slope, which is also gradient. The slope or gradient at every instance is given as ds over dt, which is equals to v. Please take note of this. ds over dt is equals to v. What is v standing for? V stands for velocity. Now, if you are to consider a graph where you have acceleration, velocity divided by time, what you get from there is dv over dt is equal to a, which is acceleration. So when you differentiate v twice, you obtain a as 1. S divided by t gives me v. dv dt gives me a. Velocity divided by time. Good. Now, before we go into calculations that has to do with instantaneous motion, I will assume that some of you, or most of you, don't have an idea about what we call differential calculus. So because of that, I will explain differentiation before going into questions and answers that has to do with instantaneous motion. Now let's take a look at this. Probably Newton was right, or Leibniz was right, but they concluded that if y is equals to a, or if y is equals to x raised to power n. They also concluded that dy over dx will be n x n minus 1. That's what they concluded. So, because of this, I can boldly say that if y is equals to x raised to power 3, then what it means is that dy over dx, following this their rule, means I will have to take the 3 backward, which is 3 times whatever is in the back, to become 3. Then I'll have x, just we have x2. Then I'll have 3 minus 1. What I finally get is 3x, 3 minus 1. Surely that will be 2. So I have differentiated this value, so it gives me this. Now, it's still the same thing. When I say y is equals to axn, so my dy over dx will also be a times n times whatever is in the back. That will be an xn minus 1. Take note of that. So if I'm having y is equals to 4x raised to power 5, dy over dx surely will give me 5 times whatever in the back, which becomes 20 x 5 minus 1, which gives 20 x raised to power 4. Oh, let's try 2 more. Let's try 2 more. Let's try 2 more. Good. Y is equals to 3x squared plus 2x. Let's try that one. Let's try y. Okay, let's try that. Let's see. So dy over dx will be, let's start with this. 3 times 2, that will be 6. X, 2 minus 1. Plus this, the power here is 1. We already know that. So 2 times 1, that is 2. X, 1 minus 1. That will give us 6x raised to power 1 plus 2x raised to power 0. Funny enough, mathematically, 6x raised to power 1 is still the same thing as 6x. X raised to power 0 will be 1. Anything raised to power 0 is 1. So 6 times 1 is 2 times 1 is 2. Good. What about we try y is equals to 4x cubed plus 3x squared minus 8. Let's try this. So what do you have now? dy over dx will give us, let's start with this. The power at the top will first hit the back. What's that? 3 times 4, that will be 12x, 3 minus 1. So plus 2 times 3, that will be 6x, 2 minus 1. And the last one is minus 0. Somebody asked me, why do you have to put 0 there? It's not that I like 0 actually, but the truth is, I have to put 0 there because the dy dx of any constant must be equals to 0. That's the rule. The y dx of any constant is 0. So if somebody asks you, what's the y dx of minus 100? That automatically is 0. The y dx of 27 is 0 because it's a constant. It has no value of x, it has no variable. So it's going to be 0. So from here I'll have 12x squared plus 6x. That is my value. So now I've introduced you to the world of differentiation. So I can now take questions in uniform, non-uniform accelerated motion. Now from the questions that we'll be talking about, you observe that from the questions we've been talking about, we have one on that non-uniform accelerated motion. We have example 1 and we have example 2. Example 1, we read, the displacement of a particle is given as this. Calculate the velocity of the particle at t equals to 2 seconds. Now, the first thing you do is that you are going to write S is 3t cubed plus t squared minus t. Now, this is displacement. Now, when you take out time to differentiate this, what you get after differentiating displacement with respect to time is that value called velocity. And the question said, calculate the velocity. This is what we're looking for, velocity. But you remember that ds over dt is equals to v. That's velocity. But how do you differentiate this value? Differentiating this value now is our first priority. Let's differentiate this value. How do you do that? ds over dt is equals to, let's do that, 3 times 3 in the front, that's 9t, 3 minus 1, plus 2 times 1 in the back, that's 2t, 2 minus 1. And this is minus 1. The ydx of t is 1. Because this value here has 1. 1 times 1 in the back, that will be 1. Then we have t, okay, let's say t, 1 minus 1. That becomes 9t squared plus 2t minus 1t raised to power 0. And anything raised to power 0 is 1. 1 times 1 is still 1. So we have 9t squared plus 2t minus 1. Now the value we've obtained after differentiating the ds dt, that value is v, called velocity, which we are looking for. But the question says, calculate this same velocity at a certain point when t is equals to 2 seconds. You know that the time is not always constant with the motion, it's instantaneous. So because of that, t at 2 seconds. So therefore, v now for t equals to 2 seconds will now become 9 into bracket 2 squared plus 2 into bracket 2 minus 1. So let me treat you like adults now. 2 squared is 4. And 4, yeah, let's do this. So 4, 2 squared is 4. Then you have 2 squared, 2 squared is 4. 4 times 9 will give me a value. So 9 plus 9 is 18. Then you have that as 36. So 2 times 2, that will be 4 minus 1. 36 plus 4, that surely will be 40. 40 minus 1, that will be 39 meter per seconds. That is the value of v when t is equals to 2 at 2 seconds. At that instant when t is 2 seconds. So now we know how to calculate that as the first. Now after knowing that, we'll move to the next question. The next question is interesting. We'll have to take this out first. Now the next question is interesting in the sense that it talks about acceleration. Acceleration, it said, example 2, if the displacement of a car is given as, this is the displacement of the car, s is 4t raised to power 3 plus 2t squared minus 3. It said, it's given as this. It said, find the acceleration of the car at t equals to 2 seconds again. 2 seconds again. It can be any value of seconds. It can be 1.5, it can be 0.2, it can be anything. So now, all that is important is that immediately that value of time is given. After your differentiation, you substitute and you are good. Now, listen. S is 4t cubed plus 2t squared minus 3. I can do something like differentiate this to get v. ds over dt. We're used to that. 4 times, that's 12 t squared plus 40 minus 0. We already know that. So automatically the value of v now will be 12 t squared plus 40. But that's not what we're looking for. We're looking for acceleration, not velocity. What we've just gotten is velocity. But how do you get velocity? Acceleration is v over dt. velocity divided by time will give you acceleration. So because of that, we'll go acceleration now is dv over dt. So what is dv over dt? Differentiating these two now, what do you get? You get 2 times that's 24t plus 4. The y-dx of this will give us 4. So from there, it gives us 4. So from there, so at t equals to 2 seconds, a now, which is acceleration, becomes 24 into bracket 2 plus 4. 24 times 2 should be 48 plus 4, and that will give us 52 meter per second squared. That's the value of acceleration. So class is an interesting topic, very, very interesting. So you can solve more questions, you can pause your video, you can take it over and over again. Thank you, and check out further classes for more topics. Thank you very much. I'm your physics instructor.